Hello friends, welcome to my channel EduPaat. So as a part of this video, I am going to tell you 7 principles of software testing. So it is very important and very necessary things to know all the tester. Okay, so today's discussions, I will clear all of the doubt, all of the things I will clear about these 7 principles of software testing. So before jumping to the principles of software testing, I just want to let you know that what is software testing. As we already know that what is software testing, but again I am telling you all that what is software testing. So as a software testing is a process. We all know that. And in this process, we have to verify and validate the behavior of any application which is under test, right? So in a simple word, we can tell that in software testing, we have to meet the client's requirement. That means we have to meet the client's requirements. So we can tell you that we can tell very easy way that expected results is equals to actual result. That is the software testing. As you already know that, and in my previous video I have already talked about with the software testing, what is software, what is testing, what is software testing, all about this thing. So if you till now if you don't see my video, the previous video, please please see the video and then come to this video. And obviously in this video descriptions I will give the link of this video, so you can directly refer from here also. Okay, so now I'm coming to the our main focusing point, that 7 principles of software testing. So we have to remember very carefully what is the 7 principles. So the first principle, testing shows the presence of defects. The second is exhaustive testing is not possible. Third, early testing. Fourth, defect clustering. Fifth, pesticide paradox. Sixth, testing is context and dependent. And number 7 is absence of error fallacy. So that is the 7 principles of software testing. So I will tell you in detail what is that exactly, what is that. Okay, so first I am coming to the first principle, that is testing show the presence of defects. What it mean? So it mean that we can talk like you that testing talk about the presence of defects and doesn't talk about the absence of defects. So that is very crucial. Testing talks about the presence of defects and doesn't talk about the absence of defects. So in software testing, we look for bugs to be fixed before we deploy systems to live environment. So this gives us confidence that our system will work correctly when goes live to the user, right? So the testing process doesn't guarantee that software is 100% defect free. It is true that testing greatly reduces the number of defects buried in software. Why? Right? So, however, discovering the repairing this problem doesn't guarantee a bug-free product or a bug-free system. Right? So, even if tester or even we cannot find defects after repeating regression testing, it sometimes it may be possible that we have missed. We already done some regression testing and we have missed some defects. That means it doesn't mean that the software is 100% bug free. So for an example, like I can tell you that an application may appear to be error free after passing various stages of testing, but when it deployed in the environment, an unexpected defect can be found. So then what will happen? Then team member should always adhere to this concept, and effort should be made to manage client expectation. So what is our ultimate goal? Our ultimate goal is that the client given us some requirement and we have to fulfill that requirement. So what will happen? The developer when develop or when coding something, so they will follow the client requirement. And obviously as a tester, when we are testing something, we have to follow that requirement document. Okay, so our first expectation is that client should be happy after when the product is ready, and when we are uploading that product to the real world or live environment. That time customer should be happy. So that is the testing, so the presence of defects. So now you are clear about what is testing, so the presence of defects concept. So now I'm jumping to the second point. Exhaustive testing is not possible. What does it mean? So if I give an example, consider just for example, a simple real world example I can tell you, that in which you have a screen that takes two numbers as the input and print their sum. It would take infinite time of validate this screen for all possible number, right? Suppose, let's say, suppose you have to validate few numbers, like you have to validate 1 to 100 number. So what we will do as a testing, first we check 1, 2, 3, 4, 5, 6, then up to 100. So that is the possible way. So we have to test. But exhaustive testing is not possible means, suppose there is a 1 lakh of numbers is there. So how can we test that? That is the funda. So in that case, what we will do? We will just test, suppose 1, 2, 3 up to 10. Then some randomly number we will choose, right? So this is a, then I mean we are not testing 1 to 1 lakh numbers. We are not testing this. We are just test some few random number, that yes, after testing the random numbers, my test case are working perfectly fine. Okay, so that this is the basic example. So if you want, if you can do that as the manual testing, or if you want, you can do that as the automation testing as per your wish. But exhaustive testing is usually test and verifies all functionality of a software application while using both valid and invalid inputs and preconditions. No matter how hard you try, testing everything is pretty much impossible. That is the true fact. There is, suppose there is 1 lakh of numbers. So testing everything is not possible from our end. As a human being, we can't do that. How we, if we test 1 to 1 lakh user, so that is very time consuming thing, and with that testing of huge number of data, so our time will mismatch. We cannot deliver the product to the customer. So that's why the inputs and outputs along have a input number, have an infinite number of combination. So it is 100% not possible to test an applications of every angle. That is not possible, right? So that is the thing. Exhaustive testing is not possible. And now I'm jumping to the third point, that is early testing. Early testing, I can tell you that in our software development, early testing means incorporating testing as early as possible in the development process. What it means? Suppose testing the requirement before coding start. We have to test the requirement. When developers start their coding, before developers start their coding, we have to testing the requirement. So for that, what will happen? Amending issues during the stages of project lifecycle is much cheaper than easier and amending issue at the end of the project. That means before testing, before development, if we test any requirement, that means at first we are getting some issues and suddenly we can fix that issues by the developer, right? So there is a low chance to mismatch our project. There is low chance to give the to get the escalation from the client. Okay, so suppose, just I'm giving an example. Let's consider two scenarios. In the first case, you found an incorrect requirement in the requirement gathering phase, and in the second phase, you found a defect in a fully developed functionality. So it is less expensive to fix the incorrect requirement than fully developed functionality that isn't working the way it should, right? So therefore, to improve the software performance, software testing should begin at the initial phase, that is during requirement analysis. Is that clear? So we have to test very early before start the developing process. That means we can easily get the requirement, we can easily test that, and after testing, if there is any defect, we can easily fix that. So that is the funda of early testing. Now I am coming to the next point. What is defect clustering? Now, defect clustering means, I can give you an example. Suppose we can, in the defect clustering, we can tell it as a Pareto principle. Now, what is Pareto principle? Pareto principle means, suppose example 80:20. Suppose we can tell it that 80:20. So that is the Pareto principle. That means what it means. That is the Pareto principle. What it means? It means 80% of defects are due to 20% of code. 80% of defect that are due to 20% of code. Why? Most believe this is some divine mandate. So it is based on the observation that 80% of the user uses 20% of the software. So it is this 20% of the software that will contribute most towards the defects, right? So this principle can help us or can help our team to focus on the right area. That is the most popular software part. So we can focus that directly, because in 80:20 means Pareto principle or defect clustering. What it says that 80% of defects are due to 20% of code. Okay, so that is the defect clustering. So now the fifth point is pesticide paradox. What is that? What is pesticide paradox? For example, just for example, consider a resource scheduling software that schedule resources for tasks based on their work timings or work timing zone and the holidays. Just for example. So what will happen? Tester or test engineer suppose wrote 10 test cases related to scheduling, and after 4 rounds of testing, all the test cases are passed. Does this mean the module is defect free? No, probably not, since it took 4 cycles of the clean 10 bugs. So what is the solution for that? Again, think and write more and better test cases where we can get 100% test coverage, where the positive test case and negative test case both are included. So we have to rethink, we have to rewrite more and better test cases, especially when it is the crucial part of the application. So preferably use a code coverage tool to ensure that your test case cover all the code paths. That means your test cases cover 100% testing coverage. Means both positive and negative test cases are present in your test cases. So in the pesticide paradox, in a simple way, the use of pesticide makes what if we give a example in our real life. Pesticide paradox means pesticide makes pets immune to its use. Pesticide makes pets immune to its use. Similarly, subjecting a module to the same test cases can make the module immune to the test cases, right? Suppose, just for example, you have you have 10 test cases. Suppose you have a login for application. You have a application that in that application you have suppose there is a login page, and the login page you have a username, password, and login button. So you have already written some test cases. Suppose you have written 10 test cases about this login functionality. So in each and every testing, suppose you have done already four type of testing or 4 rounds of testing. So in each and every rounds you covered the same test cases. So that means their 100% test case coverage is not possible, because every time you are not thinking anything, you are just executing your 10 test cases at every single round. So that's why if there is not 100% test cases possible, so for that reason we have to rewrite, we have to rethink again, we have to for the better test cases, right, where the for the particular or any crucial part of your application, right? So that is the pesticide paradox. Means the use of pesticide makes pets immune to its use, right? So in our testing life cycle or in our testing activity, it's similarly subjecting a module to the same test cases. Users can make the module immune to the test cases. So that is called pesticide paradox in software testing. Now, point number 6, testing is context dependent. What it means? For example, suppose consider 2 companies making a pen pack battery set. Just for example, 2 companies making a pen pack battery set. The first one is a premium one costing suppose $10, while the other cost is suppose $2. And that means that the first company is giving you, suppose the first company is giving you the $10 and the second company is giving the $5, let's say, or $2. That means 2 companies making a pen pack battery set or anything, or the 2 companies they are making one mobile phone, one iPhone. So for that purposes, the one company has set the premium costing of $10 and the second company has premium cost of $2. Just for example, that means the second company is 10 times cheaper, sorry, 5 times cheaper. Okay, 5 times cheaper. So do you think it makes sense for both companies to have the same QA processes? The first company, suppose this is the company A, this is the company B. So do you think that these 2 companies are the 2 companies are following the same QA processes? What is the answer? The answer is obviously no. The first company is charging for quality because their premium costing is $10. So that's why they are charging for quality. Hence, we will have more robust and standard quality control, right? Because if any company, if any mobile, just for a real-time example, so one mobile cost is 20,000 and one mobile cost is 10,000. So 2 mobiles are similar. To mobile functionality is similar? Obviously no, because in which mobile has 20,000 rupees, the cost is 20,000 rupees. That means some extra specification is there in that mobile comparing with the 10,000 cost mobile. That is a true fact. That means in your applications, don't go for strategy without understanding your cost of quality. You don't want to spend more on quality than what you get in return. Put quality in the context of your product offering. So that is the funda of context dependent is testing. Hope you are clear now. And now coming to the last and 7th principle. What is that? Absence of error fallacy. What does it mean? It is the common belief that a low defect rate implies the product is a success. If any product has low defects, that means the product is successfully running. So this idea is the absence of error delusion. In which area or in which product there is less errors, that means the product success is high, right? Same, just take the example like one mobile has 20,000 cost and another mobile has 10,000 cost. So which mobile has 20,000 cost? That means some extra specifications, some extra qualities there on that mobile. So that's why the cost is too high comparing with the 10,000 mobile. That means same like in our testing. If any product has less issue, less error, that means if there is less defect rate, that implies the product is a success, right? So zero defect do not mean that the software solves end user problems successfully. Zero defects do not mean that the software solves the end user problem successfully. Just for a real life example, all we are using Windows system, some people are using Mac system, some people are using Linux system. But if I taking these three, so Linux always had very few bugs, while Microsoft Windows has many bugs comparing with the Linux. But most people use the Microsoft Windows as their operating system because they found it easier to use and solve their problems better comparing with the Linux or Mac. So that is the concept. So we have to choose the correct way, that zero in any product, no product has, I can tell you that no product, we cannot, a single software, we cannot tell that it's a defect free or bug free. We cannot tell that. Okay, so that's why we have to choose the correct way, that which is user friendly, in which product, the product should have less error. Okay, so that means we can tell that in absence of error fallacy means where the error are less. So if we implies the error rate, then we can tell that the product is successfully running or the product is success. So that is the concept of absence of error fallacy. Hope you guys are very clear about these 7 principles of software testing, and make sure that is a very, very, very important questions for our interview. As if you are a fresher or if you are a experienced, that doesn't matter. But we all should know the 7 principles of software testing, because in our daily basis testing, so we have to follow that chart. We have to follow that testing some principle. So that is the 7 principles of software testing. So I hope you guys are now clear. So if you guys like my video, so please one thumbs up, and obviously if you guys have any doubt, just comment out in the description or comment out in my comment box, comment section, or one thing, please subscribe my channel EduPaat and click on the bell icon so that you can get my testing videos update very fast. So see you in the next video with some interesting or exciting topic. Thank you.